This is a TEVO little monster with a filament runout sensor being controlled by a DUET board running RepRap firmware. It's a fantastic upgrade, and in this tutorial I'm going to show you guys exactly how to do this upgrade to your TEVO little monster specifically, or pretty much any Delta printer in general. So this is going to be a pretty technical video, and if you're more interested in the less boring subject of all of the neat upgrades I've been doing to this printer, go ahead and click on this link right here. But if you're in it to win it and you want to see how much better a firmware can be, let's get into it. Everything I'm about to go over is listed here on the instruction page on the DUET website, and this is where you will find all of the links as well. So I will provide a link to this page in the description down below. The first thing we need to do is download the driver for the DUET board so that we can connect to it via USB. So here on the GitHub page, we just click on download. After we've done that, we go here in our little search box in Windows and type in device manager. Up pops a list of all of our devices. Now, for whatever reason, I'm not seeing the yellow caution sign that shows you that the driver has not been installed for the device. So it's very possible that I already installed this driver for a previous device that I used on this computer. But if you see a caution symbol next to a USB device, all you do is right click and then install driver. Okay, we've installed the driver, so that means we can now connect the DUET board with the computer. But now we actually need to interface with the DUET board and send it commands and that kind of thing. So in the instructions, they tell you to do that through YAT, which stands for yet another terminal. And while that is a very clean way to do this job, the YAT terminal only does terminal stuff, and so I just don't think it's that useful. I don't recommend downloading that. If you are running the TEVO Little Monster, chances are you installed it with the original hardware, which told you to use the Repetier host program. And this program has a built-in terminal, so we don't need to download anything new. So what we want to do here is on this tab, we want to be on the manual control over here, and we want to configure the printer so that the connection is whatever COM port your board is connected to. You need to figure that part out. Baud rate of 9600, and here in the printer tab, we want to uncheck the check extruder and bed temperature. Uncheck that for now. Back to connection, press OK. Let's clear this log and connect to the printer. Actually, to the DUET board here. So we are now connected, and I don't care about any of that. Clear the log, and like if I type up in here on the G-code prompt, M115, it will return this information that we need. Okay, now we need to type in the G-code command of M552, and we're going to see Wi-Fi module is disabled right there. So we need to enable that. So now we need to teach the DUET board our Wi-Fi login and password. And the way we do that is using the command M587. So M587 space S, capital S, then quotation marks, put the name of your network. Whatever it is, it needs to be exact. However, if your network has an apostrophe, you need to change the apostrophe to be a quotation symbol. It's a weird little quirk, but there you go. So in this case, I've got my network name, followed by the capital P, more quotation marks, and then the password ended by quotation marks. So let's press enter here, and it says nothing. So it turns out that I had just entered in the network ID incorrectly, and now it's all working. I am connected to my Wi-Fi, so now type M552 space S1, enter. And we have an IP address given to us. How great is that? So copy that line, open a new web browser, paste the whole line into the web browser, and then delete everything except the IP address and press enter. Cannot be found. What's going on here? Okay, awesome, I got it working. Both DUET test.local as well as the IP address are both working if I type them into the address bar on my browser. It turns out that you need to have the micro SD card fully plugged into your DUET for this to work. So what we need to do now is make sure that this will work in the future when it's not plugged into the PC. In order to do this, in the left-hand side menu, we click on the Settings item, and then we go to the System Editor tab. The current volume is not mounted. Whew, I don't know. Let's reset the system and hope it automatically mounts itself with the SD card plugged in now. Once again, settings, system editor. There we go. Config.g. And here in this file, we're just looking for the M552 command that we previously used earlier, which is right here, and it's not commented. If it had a semicolon in front like that, it would be commented out. So it's not commented out, so that means that it will automatically turn the network on every time the machine powers up. So now I will unplug the DUET from the computer and plug it into this power adapter and put this in the wall so that the DUET powers back on. Then going back to the DUET test.local, let's do a shift refresh so we know we will have flushed it, and look at that, we're still connected. So the DUET will function autonomously now, and we are in business. Now that we've got the firmware on the DUET, the next thing we need to do is wire it and install it into the printer. So first step, get rid of all this stuff that I added. Okay, so now what I'm going to do is use some of this masking tape to label all of these wire ends so that I don't have to trace them back to where they go. It will be easy. I'll just, as I unplug them, I'll label them. This is especially important for the wires that go to the hot end through this this thick cable, because I don't want to have to take that apart just to figure out what my wiring is. So once again, and there we are. We can see that the DUET board is a bit smaller than the MKS S-Base board, so we have even more room inside of the enclosure than we had before. So I've taken the front plate off the enclosure. We'll have to make a new one of those. And you can see I've labeled all of these wires so I know what they are. Now what I need to do is go through, and all of these wires that have connector ends, I need to clip those and use the special tool to put the new little metal ends onto those wires so that we can plug into the plugs on the DUET board. Now thankfully, all of the wires that are going into terminal blocks already have these great crimp connectors on them, so I don't have to do that work. So it's not tragic, but there is a little bit of wiring to be done. So one more time, and there it is, all wired up. So let's turn the power on. And we see no magic blue smoke, all the right lights are coming on, we're in business. But let me show you guys how I wired this up. This is quite important. I've removed the BLTouch probe from the printer, and if we look right there in the center of the screen, we see the little solder pads that are connected by that tiny little bridge. We need to cut that bridge so that it can run on 3.3 volt logic. That should do the trick, but just to be sure, I'm going to test it with my multimeter. To do the wiring job on the DUET means you have to install these female clip ends, and that's going to require a few specialized tools. First, and most obvious, you'll need some flush cutters. You should have a pair of these that came with the printer. Next, you're going to need a good pair of needle nose pliers, not your typical hardware store variety. You need this skinny, long, actual needle nose pliers. And you're going to need a good wire stripper. Now I love this tool. But if you're not going to do any other wiring projects besides wiring up this printer, maybe you don't want to spend a bunch of money on a good wire stripper. So something like this will certainly do the trick, but it's just not ideal. Finally, you need this DuPont crimp connector tool. And I used to try to connect these things using just the needle nose pliers. But I'm never going back, you guys. That's just a janky BS way to do this. You just can't do without this tool. So these ones here are subpar because they have metal injection molded jaws, MIM. There's a better version of these that has wire EDM cut jaws. These are the cheap version, but they will do the job. And here's how I install these little tiny crimp connectors. We get our wire end here, and we strip just a tiny bit off the end of the insulation. That'll do. Next, I place the connector in the needle nose pliers so that it's held onto just the very end, like so. And then put the wire into that end so that just the insulation is being crimped by the pliers. You may have to come back at it from the opposite side just to make sure that it's good and on there, like so. But we're not fully crimping it yet. We're just sort of keeping it held in place. We go until this little tang right there pops down. So watch the tang. Boom, that's enough. So looking here at the front side of this job, we see a decent crimp on the insulation, so that's going to hold that thing securely to the insulation, and also up here on the wire. So the wire is going to make good conductivity there. But if we flip it over to the back, we see that it is a bit mangled, and that's just because there's gaps in those teeth on the metal injection MIM jaws. So probably worth it to buy the more expensive version of this tool with the wire EDM cut jaws. And now that that job is done, we can insert it into the plastic connector end, making sure that the loop goes away from the hole in the back. There's a little tiny tang right here that's going to catch into that hole. So we just slide it on in. There we go, and it's secure. Now, there is a hack which could potentially save you some time. Here we have the end of a stepper motor wire. And what we need to do is clip off these plastic bits here and then across the top. And that makes it nice and flush, which will allow it to plug onto the DUET board. You won't have the pull back protection. In other words, it's more easily popped off the board, but the spacing is correct on these tips so that it will plug in. But if you try this trick with the sensor connectors, you're going to have to use a small screwdriver like this to sort of pry open the or push down the little tang and pull the wires out, because they line up differently on the wiring diagram. Speaking of which, let me show you guys how you wire up this board. Looking at my wiring job here, we can see that I did the thing that I was talking about a minute ago, where I reused the clips from the MKS S-base board that attached to the stepper motors, and you can just flip them around 180 degrees and they install just fine onto the DUET board. So that saves you the work of installing 16 of those crimp connectors. The wiring is all done, so let's get the firmware configured. In order to get the firmware working, the first thing we need to do is to go over to the configurator at configurator.repropfirmware.org. So we're going to do a custom configuration here. And you know what? I'm not going to go through this in detail, but you can just pause the screens and use the exact same values that I've used. I find this to be the best setup for my TEVO little monster. If you have a different type of Delta printer, you can start with these variables, but you know, you're going to have to obviously tweak it for your specific machine. So once we've got all the numbers entered in, we just click the Finish button and then download the configuration bundle. Now that that's done, we need to open up a new tab and go to our printer. We need to open the printer here. So tlm.local will get to my printer because you saw that I renamed it there in the configuration tool. Alternately, I could type in 192.168. blah blah blah. That was the IP address that was given to us when we first did the installation with the DUET attached to the computer. Okay, so we are connected to the printer now, and here on the left we're going to go to the settings menu and then we upload files. There's the config.zip that we just downloaded from the online configuration tool, and ta-da, and it asks us to restart the DUET. Yep. And if we go to system editor, we will see all of the files. Now, here in the bed.g folder, we want to add a couple of lines. First, after the G28, we want to add an M190 space S80. This is not something that you need to add, and in fact, I'm not running the printer like this anymore, but if you want it to behave the exact way that it behaved with the MKS S-base board on it, you need to put this command in here. What this is going to do is it's going to heat up the bed to 80 degrees before it runs the auto calibration. And that might be a good idea because you're almost never going to run this thing cold, and an 80 degree bed temperature is like halfway between ABS temperature and PLA temperature. So, you know, and it's also like a good bed temperature for PETG. But if you're going to run an auto calibrate before every single print, which is a good idea, the slicer will automatically get your bed up to temperature before running this whole G32 command, which activates this whole bed.g file. So it's not necessary to put this in there if you run this command at the start of every print. But it is a good idea to do a G29 command at the end of the bed.g. And what that's going to do is map the bed with a grid of points, and you know, you'll get a very accurate first layer. So you can issue those as two separate commands if you want, but I find it just most convenient to put it here with the G32 command. So the next thing we want to do is go to deployprobe.g, and we need to do two things in this file. First is we need to add an I1, capital I1. And what this does is it inverts the signal going to the BLTouch sensor. So we have to do this because we did not use the DUET expansion board. Now the DUET expansion board plugs into that big header there on the DUET, but you know, we didn't use it. We just used the little crimp connectors. So yeah, you need to do this. But the other thing we want to do is before we deploy the probe, we want to put the command M280 P3 S160 I1. Now this also is a command relating to the BLTouch sensor. So specifically, this clears the error in the BLTouch sensor and resets the pin into the upward position. So this will then deploy the pin into the lower position. Now we need to put this in there because if you power your printer on with the nozzle touching the bed, the BLTouch probe tries to go through its starting algorithm, its self-test algorithm, and because the probe can't fully deploy, it causes the BLTouch to trip an error, which means that it won't deploy the next time you need to use it, and then when it thinks it's deployed, when the printer thinks the probe is deployed, it's not, and you just get a collision between your nozzle and the bed. So by putting this on, we clear the error before we deploy the probe. So this is the way to do that. So save those changes, and then go back down here to retract probe, and also add an I1 there as well. Save changes. And that's pretty much it. We can take a look here at the config.g file. Now this is where all of the variables that we entered into the configurator are stored. And really, conceivably, you could just get this configuration file from somebody. If you want to get it from me, follow the link in the description. So down here we see custom settings, and this M591 command is for the filament runout sensor. So this P2, if you get a different type of sensor, you're going to want to change that to 1. Okay, it's just a matter of whether the switch is naturally open or naturally closed. All right, well that's about it. So save changes, and once we save things, it asks to restart the DUET. Of course we want to. And we are in business now. The DUET should be fully functional. So there on the right side of the screen now, you can see the printer across the room. And I'm just going to click on Home All. And you see what it did there. Now I can send a G0, Z0 command here in the G-code command box. And we see that the printer is going to lower down to what it thinks is the 000 coordinate, but it's actually quite a bit above the bed because we told the bed that it was 520, but it's actually like 525, 530, something like that. Okay, so another way to do G-code stuff is with the G-code console, and this returns whatever the printer reports to you. So if you ask like M114, which should tell us 114, which should tell us the status of everything, it reports to us the status. Although we're seeing all that right up here, so we really don't need to do that sort of a deal. So back to just this box. I like it a lot better. Now what we can do here is jog the printer manually. So let's just raise the Z by 10. Or let's bring it to the left with the, so that would be X minus by 10. X plus by 10. Fun, okay. Back to Home All. And now probably the most involved task in getting this firmware set up with the printer. We need to set the trigger height. That's the same as the sensor offset in Marlin. So we just did the auto home. Now the next thing that we need to do is enter in a command into our G-code box, which is M564S0. And what that's going to do is allow our printer to travel into negative space, so below the 000 coordinate. So once again, G0, Z0. Here on my phone, I've made this little desktop icon, which is a shortcut that opens up the web page to the printer. Now up here at the top, I can just connect to the printer. And of course, this interface has all the functionality that it does on our PC. So right here are the buttons that allow us to jog the printer in the Z direction. And we're going to use that functionality right now to do the typical height calibration, Z height calibration using a piece of paper. And back here on the PC, we see that my Z height is now negative 6.3 millimeters. That's interesting to know. And the interesting thing here is that it did not disconnect me from the printer on the PC. So I was logged in with both the cell phone and the PC. You may have to reconnect your PC, but it really doesn't hurt anything to jump back and forth between having the PC connected and the cell phone connected. Our next command is G92Z0. And what that's going to do is set relative coordinates and then define that Z offset as 0. So we are going to just tell the printer it's at 0. So hey, look at that. Z is at 0 now, even though the printer has not moved. So now we want to move the printer up just a hair. So let's move it up by 5. And finally, we need to probe this one specific point just to get an idea of the sensor relative to the nozzle. And the command to use the probe for just one point is G30 space S -1. And we see 1.93 is our Z offset. So that value right there, that is our trigger distance. Going back here to settings and system editor and then config.g, we do a search, Control F for trigger. And right there, that Z0 gets changed to 1.93. And yes, we do want to restart. So back to machine controls here, we want to home all. And then we want to hit this button for auto delta calibration. And what it's going to do is get that bed up to 80 degrees here. And once that's happened, it's going to run the whole auto calibration routine. And now that that's done, we see it gives us this height map. So this bed is pretty atrocious. Look at that. That's how far it is off. So 0.25 millimeters down to, I guess we're just in the green. So we're plus or minus 0.25 millimeters on this bed. But now it has the bed mapped, so the print will definitely stick to the bed, and we are ready to send a print. So we'll just close this and go to the G-code files menu. And we see here that I have no files or directories found. So let's upload a G-code file. So we'll just open that. Close that, and once it's open, we can just double click, and it says that we want to print it, and of course we do. So it will start printing here as soon as the bed, well, I guess the bed is up to temperature already because it's still at 80 from doing the test, and so it's just going to get to that nozzle to 200, and we are good to go. Now that that's printing, let's take a look here at Kira. Specifically, we need to look at the start and end code. And this is going to be the same for any slicer software you're going to use. The important part here is the start code, specifically these two lines. So I have a G32 command. That is the auto calibrate. Now, G32 all by itself will just auto calibrate the printer so that it adjusts the rod length and that kind of a thing. But you'll recall that we added a G29 command to the end of our G32. So that will do a mesh bed leveling algorithm, map the bed. Now, I have it currently set up to where it's just going to recall the previous mesh bed leveling algorithm. So G29 S1 just brings up that old map. But if you wanted to redo it, you could just comment that code out right there and uncomment that line, and then you're going to get a G32, so you know your print is going to work every time. And in fact, it takes a minute to do this, the bed mapping and all that, but it might be worth it. You're guaranteed to get a good print first layer every time. And before you send a print, here in the web interface for the DUET, you can actually go to your G-code files and edit a file so that you can comment out the G29S1 command and comment in the G32, or do the opposite. Then just save it and it'll print that way. We can see that the print is proceeding nicely, so let's go see if we can't mess that up by running out of filament. So actually I'm going to change the filament to a different color right now so we can see right where the join happens. Okay, the filament has been changed, so I'm just going to close down this error and then click the resume button right here. All right, let's try something that I have not yet tested. That's the print resume on power loss. So I'm just going to go over there to the machine and unplug it and see what happens. Here on the web connection, we see the error that the request timed out. If we connect, so it's not immediately obvious how we are supposed to resume a print once it has had power loss failure. Clicking the home all button, go back to the print status, and I don't see. Oh, look, that's horrible. So the extruder oozed, and the ooze stuck to the print, and the print wasn't adhered to the bed very well, and it lifted the print when it did the auto home. So clearly still some work to be done to figure out the print resume on power loss function with the DUET. So here is the test print printed with that 0.4 millimeter nozzle. And we can see this little goober right here. And that's because I didn't clean off the nozzle tip when I primed it with the yellow filament. So we see the transition between red and yellow, and that was just a little bit of red left sort of dribbling off the nozzle as I resumed printing. But other than that, it's a pretty seamless recovery from running out of filament. I'm really impressed with that. What I'm not impressed with is that big cavity right there where the nozzle that was still hot ended up, colliding with the part after the power loss happened. So basically the stepper motors are not powered on when it loses power, and so the whole nozzle just fell and it was able to melt its way into the part. So even if we were somehow able to get the printer to resume printing right where it left off after a power loss, we'd still have to worry about what it's doing when it doesn't have power. So really we need some sort of a battery backup system to get that nozzle clear and hopefully in a place where it's not going to fall into the part like that. So at this point I should tell you guys about the forum over here at DUET3D.com. You're probably going to have some questions with your installation, and this is the place to ask them. There's a lot of power users as well as people who work at DUET oftentimes will chime in with good questions here. But probably your question has already been asked, and you can just do a search for previous questions. There are a number of write-ups separate from the forum. They're just sort of how-tos, which are also very helpful. So all in all, the documentation is phenomenal for this board, and it's all written by native English speakers. So highly recommend you get a username here on the forum and start talking to these folks if you're going to do this installation. And that's all it takes, you guys. Now, I did one final thing, and that's because I don't have a perfect photographic memory for memorizing G-codes. So I actually made a custom folder that includes the macro buttons that are the step-by-step buttons that you would push, the commands, to calibrate the nozzle height relative to the BLTouch sensor. And we went over that process here in this video, but having it in the macros folder allows me to easily change out my nozzle from the 0.mm nozzle, which I currently have on there. And go ahead and watch the other video if you want to see just how great a 0.8mm nozzle is on this printer. But yeah, I can switch from 0.8 to a 0.6mm nozzle, or even back to the 0.4, but I don't think I'd ever do that. So yeah, go ahead and follow the link in the description down below if you want to download all of these files from me, including the plant stand STL from the last video, the STL for the sensor runout switch, and all of the configuration files for the DUET board. There's a link that tells you how to do that. And also, if you need some of the tools that you saw in this video, there will be links in the description down below for those as well. So that's about it for this video. Please click all the good buttons down below, help me out in that way, and thank you for watching. See you next time.